Okay. Went too far. Did it again. There we go. It's at the bottom. Okay. So, you remember when we did rational inequalities and we had to find zeros at the top and zeros at the bottom and we did a sign chart? Okay. Same kind of thing is going to happen here. All right. Same kind of thing, except we're going to have to think a little bit about the nature of our logarithms and what they mean. Okay. So let me show you what we're going to do. All right. I like to say that it's similar to solving rational inequalities. All right, so just as a clue that we're going to use that sign chart. Okay. Now, how do we get values that are going to be on our sign chart? Well, this is where it's a little different. We have to think about the domain issues that are going to be involved, all right? And those are the numbers that are going to go on our chart, okay? So our domain issues are the numbers that are going to go on our chart, right? I want to show you what I mean by that. Okay, so the first thing we have to do when we look at this, when we're doing an inequality, here we want to find where is f of x greater than 0, okay? So when we get to our sign chart, are we looking for positives or negatives? Positives, okay? So I'm looking for positives, so I'm just going to make myself a note, okay? I know that I'm greater than 0. I'm looking for positives, all right? What I want to do next is to think about all of the things that could happen with this function, all right? Because I really can't solve this unless it's one logarithm, all right? So how can I put that one thing together? I would divide. So I would have the log of x squared minus 4x plus 7 over x plus 3 has to be greater than 0, okay? That's kind of what we're solving. Right? Now, we got to think a little bit about what we know about logarithms, okay? First of all, because it's rational, my denominator is going to be an issue, right? What can I not have in that denominator? I can't have a 0, okay? And just the denominator, I can't have a 0. So x plus 3 has got to be greater than 0. What does that mean x has to be greater than? -3. So that's one of the numbers that's going to go on my chart, okay? It has to be greater than -3 because it's in a denominator. Right now, I don't really care that it's inside of a logarithm. I'm just thinking about the rational function that's there itself, okay? Can't have -3 in the denominator, all right? Now I want to consider the whole thing because it's inside a logarithm, all right? Now, we got to think a little bit about logarithms, okay? We know that what's inside the logarithm has to be greater than 0. It has to be positive, okay? But in order for that entire logarithm to be greater than 0, okay, what value has to be in my logarithm for it to be exactly 0? That's a question, okay? If I had log base 2 of some number, what number would need to sit there so that I would get 0? 1, okay? That means that that expression, because I want it to be greater than 0, that entire expression in there, not only does the whole logarithm have to be greater than 0, but the inside stuff has to be greater than 1, okay? Because 0 is the number that's out there. So this is the inequality that I'm actually going to solve. Okay, so x squared minus 4x plus 7 over x plus 3. Now, question about that, because that's the hard part. The rest of it's easy.
Why is it log base 2?
I just made something up. That was just we were just trying to figure out what number had to be here for it to be exactly 0. It always has to be 1. Okay? No.
So does it always have to be, or is every inequality gonna have to be greater than 1?
Well, let's see. We're going to do in a minute where it's not 0 on the other side. We'll talk about what changes.
Okay.
Okay? All right. Anything else?
And on the bottom, we just have to make sure it doesn't equal 0.
Yes. Okay? So because it's rational inside, the denominator has to be greater than 0. Okay? That's just because it's rational. Because it's a whole logarithm, the whole logarithm has to be greater than 0, which means all of that inside stuff has to be greater than 1, because the only number that can be inside to give me 0 is 1. Okay? So if I had ln of 1, it would equal 0. If I had just plain log of 1, it would be 0, right? Because anything to 0 power is 1. Okay? So that's where that came from. All right, so here's what we're going to do next. Let's simplify this. I'm going to multiply by x plus 3. Okay? So that I get x squared minus 4x plus 7 is greater than x plus 3. All right? I multiplied by that denominator to clear the denominator so that I don't have a rational function to deal with. All right? It's quadratic in nature, so let's pull it all back over, right? So I have x squared minus 5x plus 4 is greater than 0. Okay? If I factor that, what numbers would I get inside of there? Yep, minus 4 and minus 1, which means my x values are 4 and 1. Okay, so again, let me stop right there. Question about what I've done so far. Okay. All right, these three values that we have gotten are the numbers that are going to go on my sign chart, right? So when I go to my sign chart, right? Now, here's the crazy thing. Notice they're all greater than, all right? Is anything less than? No. So that smallest number is where I start. I don't have to do anything to the left, all right? Because everything's bigger, all right? So I have negative 3, I have 1, and I have 4, all right? Now, when I plug in values, right, I'm going to plug it into this expression, x minus 4 times x minus 1. Okay, that's what we're going to plug it into, all right? Because that's the part when we simplified right here that had to be greater than 0 when we solved it. Okay, so that's where we're going to put it. It's the easiest place to check it, all right? So let's do that. Let's pick a number between negative 3 and positive 1. What number would go in between there? All right, we could do negative 2. We could do 0. Would even be easier. Okay, if I do 0, I'm going to get a negative times a negative, which is a positive. Okay, which is a positive. If I choose a value between 1 and 4, 2. Okay, so there we go. All right, I almost said something bad. All right, if I plug 2 in there, 2 minus 4 is a negative. 2 minus 1 is a positive. A negative times a positive is a negative. Okay, and then finally something bigger than 4, we'll put a 5 there. Plug them in. 5 minus 4 would be a positive. 5 minus 1 would be a positive. A positive and a positive is a positive. Okay? All right. Now that we've got our sign chart, we've got our pieces, let's write our solution. All right. So it comes from our chart. Okay. So we're looking for where it was positive. Well, it started at negative 3, but now notice that it has to be greater than negative 3, so we don't include it. And it was positive up until we got to 1. And then we started at 4, and we go forever. So that's the solution to that inequality. Set that down, step back, kind of digest through that for a second. Right? Inequalities are the toughest. But I'll tell you this. I looked on 2 of the practice tests, and I didn't see one. It was only on 1 of the tests. So I would assume maybe 1 problem on the entire 8 weeks in. Just as a heads up for logarithmic inequalities. Okay, so.
Any questions?
I knew you were gonna ask me. I think it's 24 total on the multiple choice, and then, I might be wrong about that. 24 total on the multiple choice, and there are 4 free slots. Okay, but,
It's 3 hours?
yeah, pretty much. They give you plenty of time.
The class one was 1 million.
3 hours?
It's a little less than that. The calc one's like 3.5.
That's my 1 million.
Are any problems?
Okay, but
I get it.
I always spread it once.
I may be a little more than 24. I'll have to go back and look. I don't remember.
I feel like 8.
I just started looking at the problems, and I'm like, oh, we can do that one now. Oh, we can do that
No
one
wonder
now.
I can
Oh, we
smell
can do
you.
that one now. Like, I get excited when I see them.
A little bit. Not as much as yesterday.
Yes.
But you're getting used to it.
There's a sink right in here. If you'll just go
Where?
in this room.
Class in there?
Yeah, there's a class in there. Just walk in there, wash your hands, come right back out. It's okay. Or there's wipes right behind you.
Yeah, I'll use a wipe.
Okay.
That's retarded.
All right. Question on that. That was a lot. We're going to do one more. Okay? It was a lot. You really have to think. You don't have to think as hard on the exponential ones, and that's the one we're going to do next. Okay? All right. Switch it over. Where'd it go? I know I got one.
You said exponential ones, you don't have to think as much?
No. Inverses of logarithmic and exponential equations. The good news is finding an inverse doesn't change regardless of what the function is, okay? Just the style we have to solve or the inverses we use changes a little bit. But basically, we're still going to do the same thing we've been doing. We're going to switch x and y, and we're going to solve for y. Okay. So that process for finding an inverse doesn't change. It doesn't matter what kind of function is. We're still going to use the same algebraic process. All right. So this really falls into what we did yesterday, or where we ended. So I think it's a good place to start today. All right. Okay. So let's take a look at this one. Gave you a lot of space to work on that one, where it says f of x is equal to 3 times 2 to the x plus 4 minus 15. First of all, which variable is y? F of x. So I'm going to go ahead and make that x equals 3 times 2 to the y plus 4 minus 15. Okay, so we just switch x and y. It's that reverse mapping that's allowed because of the definition of an inverse. Now, we want to try to get that y by itself. Well, it's an exponential function. So when we were solving exponential equations yesterday, we had to isolate the exponential piece. Okay, so which value there's a lot of numbers. Do you think we need to move first? The minus 15. Okay, so we're going to add 15 to both sides. So I'd get x plus 15 equals 3 times 2 to the y plus 4. All right. What do you think we should do next? Good. We're going to divide by that 3. I'm going to change that green because I don't like it. So we're going to divide by 3, right? And you can leave that x plus 15 over 3. If you wanted to do x over 3 plus 5, you could. Okay, it's not required. All right, equals 2 to the y plus 4. So now we have the exponential piece by itself, okay? And once the exponential piece is by itself, we can rewrite this expression in logarithmic form because the inverse of an exponential is a log, all right? So what's going to be the base of my logarithm? Log base 2. What's going to go inside the logarithm? X plus 15 all over 3. And it's going to equal my y plus 4. Okay, so we just rewrite it in logarithmic form. Okay, and now to get the y by itself, what do you have left to do? Subtract 4. Remember, that's not subtracted inside that parenthesis. It stays outside that logarithm. So I'm going to go ahead, if it's all right with y'all, and just change my y to f inverse log base 2, x plus 15 over 3, and then minus 4. And that is my inverse function. Okay, so that's a lot like what we did yesterday, except we're not finding a value. We're just rewriting.
On like the last step that's green, can
Yeah.
you just do 2 to the y instead of 4?
No.
Subtract 16.
No, because that would be a constant, be 16 times 2 to the y. Yeah. Okay. All right. Well, let's do an inverse the opposite direction. Okay. Let's do an inverse the opposite direction. So let's look at that one. Oh, get this exponential one. Nope, just kidding. Okay. So let's look at the exponential one. The nice thing about it is it's a little bit more straightforward. We're still going to use a sign chart, but it's usually not typically as difficult. With this one, however, I want you to look at, helps if you turn your pen on. How the equation is set up, okay? It wants me to find where k of x is less than or equal to negative 31. So it gives me a very different value from 0, okay? So we want to know where 1 minus 4 times 2 to the x minus 3 is less than or equal to negative 31, okay? Usually with the exponential ones, they just work out nicer, and you may be able to solve it without even using a sign chart, which is nice. Okay, the log ones will definitely have to have that. If we're thinking about normal, how do we solve an equation kind of problem, what would I do first to try to isolate that exponential part? Yeah, we're going to subtract that 1. Okay. So I get negative 4 times 2 to the x minus 3 is less than or equal to negative 32. Okay. Now, this is where you got to remember your algebra. All right. What are we going to do next? Divide by negative 4. Anything special happen in inequalities when we divide by a negative? You got to flip the inequality symbol. So it would become 2 to the x minus 3 is greater than or equal to 8. Okay. There's this nice proof. It's because of positive and negative numbers when we're thinking about, because a negative times a negative is a positive, it changes the direction of the inequality. Okay. It just changes the, like, which way you're actually going on the number line. Okay. All right. So now we have an exponential equation, one that's not too terribly difficult to solve. You could rewrite it in log form if you wanted to, or could I rewrite 8 with a base of 2? What is it? 2 to the third. So this is the same as 2 to the x minus 3 is greater than or equal to 2 to the third. Okay? If my bases are equal, what's true about my exponents? They are equal as well. So I have x minus 3 is greater than or equal to 3. Can I solve for x? Yeah. Much better, right? Okay, I gave you the worst one first on purpose. Okay. You're welcome. Oh, it's positive, yes. I can't do math today, sorry. Yep. Yeah, you can make it a logarithm. It still works. Log base 2 of 8 is 3. You'd have to simplify it.
And it's a whole lot easier.
That's fine.
I really understand the logarithm.
That's fine. Yes, sir.
Confused when you go from included.
Okay. Exponential equations, if the bases are equal, the exponents are equal. Okay. All right, we're not going to do this one because I wrote a number down wrong, so we're just not going to do it.
Do we not do the sign chart?
Not on this one because it worked itself out so cute.
So that's it?
That's it. Okay. Your answer is 6 to positive infinity. Okay. Now, with 6 to positive infinity, do I need a parenthesis or a bracket?
Bracket.
I need a bracket because it's equal. Okay.
But if we just left it as. X
This right
is
here.
greater
Yep. That's
That
good.
would be wrong.
Nope, that's right.
Oh, okay.
That's right. Either one, they're same notation. Okay. All right. Now let's go back to that last page, and I want to do that one more example that's there. It's an equation, and I have to tell y'all, it was tricky. All right. Example 11. Okay. It threw me for a loop. I had to study it for a second. Okay. No guarantee that you'll see one like this, but I like to show you possibilities. Okay. Because here's the thing about an AP exam. They give us the structure of the test, but they don't say, like, you're going to always have 5 exponential equations on there. You're going to always have 3 transformations. Like, they don't do that, okay? Nor do we know how they're going to ask the craziness of the question, okay? And believe me, they get super creative. These people, I hope they get paid a lot of money because they do a really good job writing problems, okay? Okay. So it says to find the inverse of this function. Again, same process, all right? But this time we're going to start with a log instead of starting with an exponential function. So I'm going to have x equals -3 log base 5 of y minus 4 and plus 6. I'm legit like sweating through my clothes right now. It is hot. I'm having a flash. Whew. Okay. Gonna be 50. All of my friends in our reunion group from high school, they all started, because we're all turning 50 this year. So they put out a thing, who's 50 already? And I'm like, not me. Anyway, we had the best time at our last 30-year reunion, y'all. It was so fun. At our 20-year, we did I did this big balloon arch, and I don't drink, but most of my graduating class does. So we were at, when they had drank the bar dry, they went and got, let me turn this off. Subtract that 6 to start. Okay. So I have x minus 6 equals -3 log base 5 of y minus 4. Okay. What next? Divide by -3. Okay. Again, x minus 6 over -3 equals log base 5 of y minus 4. Okay. If we're trying to solve for y, we got to get y out of that logarithm. So that's going to take what? Change it into an exponential. Okay. The base of my exponential function is going to be 5. My exponent, x minus 6 over -3. And then it's going to equal y minus 4. And then what's my last step? No, it's already minus.
Or
We'll add it. So I have f inverse equals 5 to the x minus 6 over -3 plus 4. Okay, so inverses. Too terrible? No, they're not bad. I think it's actually better than some of those crazy equations we did yesterday. All right, so if you start with a logarithm, you're going to eventually use an exponent. If you start with an exponent, you're going to eventually use a logarithm. All right, because they're inverses of each other. I do want to go ahead and do number 10. And then we're going to go back to inequalities. All right, so I really like number 10. It's a good question. To me, it's very AP-esque because they're trying to use so many different variables you can't figure out what you're supposed to do. Okay, so it says let h of x equal 3 to the x plus 1 minus 2, and k of x is h inverse. For what values of x does k of x equal 1? All right, so now let's just kind of walk back through everything that was just said there. Okay, so we've got h of x, and we've got k, which is the same thing as h inverse. Okay, so just for the sake that I don't want 9 million variables, I'm just going to call k h inverse. Okay, instead of calling it k, I'm not going to worry about it. Okay, and so it wants to know where is k of x equal to 1. In other words, where is h inverse equal to 1? All right, so let's think about, that would be a y value, all right, on h inverse. If it's a y value on h inverse, what's it going to be on h? an x value. So really all I'm doing is h of 1 on that problem. Okay, but we have to understand that inverse relationship, okay, that they gave me a y value for h inverse, right? So I'm going to have to find the, that matches the x inverse for, the x value for x. So 1 plus 1 and then minus 2, 3 to the second minus 2, 9 minus 2, which is just 7, okay? And that's all we have to do on that problem. I don't know what number that looks like, but it doesn't look like 7. There you go. Okay. Question about that, just using that knowledge of an inverse to figure out what they actually wanted me to do. Okay.
Okay. Makes sense.
Okay.
Yeah.
And this is something like this process of understanding what inverse ordered pairs do, super important in calculus, all right, for a couple of standards that we do. So that's why that's why they put so much of it in here. Okay. All right, so let's jump back to our inverses, all right, which was on page 3. All right, then we'll come back and finish out everything we got left. So let's jump over and look at this last one, right? Now, it's a logarithmic equation. What do you notice about it when you start? They have different bases, okay? So you remember when we did the exponential equation that had different bases, okay? It was weird, okay? It was where we had to distribute. Y'all looked at me crazy because we distributed an ln of 2, and we took an ln of both sides yesterday. Go back and look. You'll remember it when you see it. It was right before we did the e to the x one that was in quadratic form, and y'all were like, it was complete mutiny, all right? I thought some of y'all were going to, fire the cannon. All right. Okay, so let's look at this one, all right? So the crazy part about this is that we've got two different bases. Log base 9 of 8x minus 15, and I've got log base 3, right? So I want to step away from the logarithms for just a second, all right? And I want to think about their inverses, which were exponential functions, all right? I want to think about 3 to the x and 9 to the x, okay, for just a second, all right? 3 to the x and 9 to the x. If I start plugging in values, right, if I plug in a 0, 1, 1, 3, 2, 9, right? If I go to the next one, 0, 1, 1, 9, 2, 81, okay? We could keep going, right? 3 to the third would be 27. 3 to the fourth would be 81. Okay. Do they share some of the same y values? Yes. Okay. They do. They share some of the same y values. So they share 9. They share 81. Okay. They go on and they share several more out after that. Okay. Now, for every one, okay, jump on 9 to the x, how many jumps does it take for 3 to the x? 2. Okay, so for every 1 on 9, it takes 2 on 3. Okay, it takes 2 on 3. So, right, if we're looking for some equality there, log base 9 of some value is the same as half of log base 3. All right, does that make sense? Oakley, nope. All right. Okay. Because on 3 it takes me 2, but I don't want it to take 2. I want it to take the same number of leaps, so it would be half as many leaps if they were the same. Okay? Be half as many leaps if they were the same. 3 takes 2. 9 takes 1, so I need half of the leaps on 3. I know, it's all crazy confusing. All right? Okay. I know, I'm good. All right, so we know on 9 it takes 1 leap. On 3 it takes 2. All right? So in order for these two things to be equal, I need the 3 one to happen in 1 instead of 2. So I had to split it in half. All right? Okay, I had to split it in half. I need it to happen in 1 instead of 2. All right, and half of 2 is 1. Okay, so here's what we're going to do. All right, here's what we're going to do. We're going to do some equality here. All right, because if the inside stuff is the same, the relationship is half. Okay, so let's do this. Log base 9 of 8x minus 15 would equal half of log base 3 of 8x minus 15. Okay, so that's the equality right there. If we're just thinking about that one side, right? Now, in order for me to solve this, I need my two sides to be equal. So we're going to do some nifty substitution. I'm going to take that log 9 out, and I'm going to put this expression in its place, okay? Because here I have log 9 of 8x minus 15. They're equal. So I can just do a quick switcheroo. I can do a replacement. So this equation is going to become 1/2 log base 3 of 8x minus 15 equals a plain log base 3. Right? So I took my original equation and I just replaced that log 9. Right? My log 9 is half of a log 3 that matches it. Okay, just did some substitution. This is my step that tells me what's equal to what so that I could do some replacement. Okay. Now, I got a log equal to a log. As long as I don't have that 1/2 in the front, then the inside stuffs are equal. Okay. What can I do with that 1/2 for that logarithm? I can make it an exponent. So this would be log base 3 of 8x minus 15 to the 1/2 equals log base 3 of x. Okay. Now, just like in the problem with the inequality for exponentials, if the bases are equal, the stuff inside is equal. So we can say 8x minus 15 to the 1/2 is equal to x. Okay. And that's the equation we want to solve. All right. Now, how are we going to get rid of that exponent of 1/2? Not a square root. We're going to square it because it's already a square root. So we would square it. This is the same thing as square root of 8x minus 15 equals x. So we're going to square both sides. Okay. So I get 8x minus 15 equals x squared. Well, now that's a quadratic, and I know what to do with those. What are we going to do? Yeah, take it all to one side. So I'm going to get 0 equals x squared minus 8x plus 15. Does it factor? Yeah, minus 3 minus 5. And so what does x equal? Positive 3 and positive 5. Now, it was a log equation. We should double check it. All right. If I go back to the original and I plug in 3, do I get a negative inside either one of my logarithms? Nope. If I plug in 5, nope. So they're both solutions. Okay. Now, I don't really look for them to give you something like that, but I wanted to show you one. All right. I thought it was an interesting problem and a good way for us to practice our knowledge of logarithms. Okay, and exponential functions. It's a good problem. All right, that's it. Okay, in terms of the lesson. All right, that one's tough. All right, that one's tough. Same lesson practice I gave you yesterday. All right. Now, that being said, are there any that you've already worked on that you have questions on that you want me to talk about now? Okay, remember Monday we have our quiz. All right. So make some notes to yourself. Monday, quiz 7 through 12. Okay. Covers everything, all right, from composition inverses to the basics of all the things of logarithms, but not the equations and inequalities. Okay. Your progress checks are open on AP Classroom. Okay, and they will close at 8:15 next Wednesday. So what would that be? Wednesday, the 13th. Okay, so just so you know, and then I'll open them back up. Okay, I want you to be able to check your work, those of you that have done them. Okay. Test next Thursday. On Pi Day. How appropriate that you should have a test on Pi Day. Yeah, 3.14, 314. It's also, is it Einstein's birthday? Pretty sure. All right, and then we'll do corrections next Friday and call it done. All right, and go on spring break and join our time off. Come back and hit trig. Okay. Trig's my absolute favorite, just so you know.